Hi, I'm Calvin Campbell, period 3, Mr. Farrar's class, and this is the AP Calculus 2010 FRQ for response number 2. So, we see a chart here, and then we begin by reading. So, a zoo sponsored a one-day contest to name a new baby elephant. Zoo visitors deposited entries in a special box between noon, t equals 0, and 8 p.m. t equals 8. The number of entries in the box t hours after noon is modeled by a differentiable function e for 0 is less than or equal to t less than or equal to 8. Values of ET in hundreds of entries at various times t are shown in the table above. So we see that they're entering names into these boxes between 0 and 8 hours. That competition in 8 hours. And this ET function shows us how many names are in the boxes in hundreds of entries. So at 8 there's 23, at 0 there's 0. So problem A is asking, use the data in the table to approximate the rate in hundreds of entries per hour at which entries were being deposited at time t equals 6. So computations that lead to your answer. So it's asking us to find the hundreds of entries per hour, which would be the derivative of the ET. And they're asking us to find it at 6. So we see that they give us the time 5 and 7, but not 6. So we want to find something somewhere in between that. So E prime equals 6 is what we are looking for. We do this by using the slope formula. This is S of B minus S of A, B minus A. For our problem, A is equal to 5 and B is equal to 7. So we get E prime of 6 equals E7 minus E5 over 7 minus 5. We look here, see 7 at E7 is 21. So we get 21 minus, we see 5, 13, 13 over 2 equals 400 entries per hour. And that is how you do problem A. Moving on to problem B, we see it's use a trapezoidal sum with the 4 subintervals given by the table to approximate the value of 1 over 8. This, using correct units, explain the meaning of this in terms of number of entries. So we are trying to find the meaning of this function, and the units of this, well, the meaning of it is 100 of entries in the box. We get this by just eliminating everything, seeing ET matches up with hundreds of entries in the box, and then we see it's between noon and 8 p.m. between time 0 and 8, because those are the restrictions they give us with this interval 0 and 8. So when finding the trapezoidal sum, if we have a function like this and we have our time of 2, time of 5, time of 8, we split it up into branches like this, and we're finding the areas of these individual sections. So our trapezoids are going to look like this, and our area function is 1/2 height base 1 plus base 2. This distance is the height. This will represent base 1, and this will represent base 2. So we can split up our function to look like this. E of t dt. We're splitting up into the time intervals that they gave us and directed us to split it up into. E of t dt. And when we transfer this over to look like a trapezoidal area, we get 1 over a, we get that 1/2, so we get that 2 on the bottom. We find the height by looking at this distance, so that is the distance between this point and this point for the 0 and 2, so we get that as 2. And then we just add the bases, which would be the hundreds of entries at the beginning and end of the time interval, so 0 and 4 for this one. And then for time, I am just going to fill in the rest as it would be. Plus 21 over 2 plus 1, 21 plus 23 over 2 equals, and you simplify this enough and you get that it is equal to 10.688 as your answer. Moving on to part C, we get at 8 p.m. volunteers begin to process the entries. They process the entries at a rate modeled by the function p, where p of t equals t cubed minus 30t squared plus 298t minus 976. Hundreds of entries per hour for 8 is less than or equal to t less than or equal to 12. According to the model, how many entries had not yet been processed by midnight? So this is saying that from 0 to 8, people are dropping off names entries into these boxes. So entries are adding up inside the boxes. From 8 to 12, they are taking out all the entries that are in, or as many as they can that are in that 4-hour time interval. So in order to find that the entries had not been processed yet, we're going to take the max number, which we would get from 8, this 8 value. So we get E of 8, and we subtract that from the amount that they're taking out in those 4 hours from 8 to 12. So we create our antiderivative here. We plug in our p function, which is the rate of them to how they're taking it out. So put in the t function. And then from here we can simply use a calculator to solve this. And so here we are. Ta-da, calculator. So we will go to the calculus, find the derivative, antiderivative, plug in our function, so x cubed minus 30x squared plus 298x minus 976. Then we will put in what our unit is the value of, and then we will put in our function or limits, and we'll find what that is equal to. And we get negative 16, which is only it's not supposed to be negative. I flipped the values. I flipped our interval, but so e of 8. So this will be minus 16, and we get this e of 8 is e of 8 right here. 23 is equal to 700 entries. 700 entries are left over that are not taken out. And for part D, according to the model from part C, at what time were the entries being processed most quickly? Justify your answer. So for this, we are going to want to take our function. We're going to want to take our function right here and find the derivative. And in doing so, we will get this. And in order to find our maximum value, which is our process most quickly, we will set it equal to 0 and solve for these zeros. We are solving for these critical points. So we bring back the calculator, go to math, go down to zeros. We will plug in our function, 3x squared minus 60x plus 298. Put it in terms of x. Find our zeros. We get 9.18 and 10.82. So our zeros, 9.18 and 10.82. We will plug these back in to this p equation. So we will plug p of 9.18, p of 10.82, and then we will also plug back in our interval values at the very limits to see where those are. Make sure they're a min or not a min or a max. So we get 5.089. For time's sake, I will be just doing these without showing you guys the work. You simply just plug these numbers for the t values in this equation. 10.82 will be equal to 2.911. 12 is equal to 8, and this is 0. And this is our max value. Hence, this is at t equals 12 is where they're processed the most quickly. Thank you for watching my video, and I hope you enjoyed.